Okay, so we're back and we want to talk about what does dust do? Well, dust blocks visible light. So if you look at the picture there on the left, it shows the constellation Orion. Now, of course, there are not those lines that are connecting the stars when you look up into the sky, but you should, when you look up into the sky, you should be able to recognize the three stars that are in the belt of Orion. And so this is showing what Orion looks like using visible light. Notice how dark it is. Now, if there was no dust at night, the sky would be completely white. So how is that possible? Because basically at night when you look up into the sky, you're always going to be looking at a star. It's just that those stars are very far away, so they're going to be dim, and also dust is getting in the way, blocking that light. So if there was no dust, the sky would be completely white at night, because no matter which way you would be looking at a star. But the night sky is very dark because of dust. So dust blocks visible light. However, look at the picture on the right. So that is a picture of the night sky using infrared light, infrared radiation. And you notice now that it's all lit up. And as a matter of fact, the brightest spots in that picture are where stars are actively forming. So I like to think that a rattlesnake, which can see into the infrared part of the spectrum, because a rattlesnake has pits on either side of its nose, and they use that to be able to hunt at night. So I wonder, what does a snake do when it looks up into the night sky? Does it see the night sky like that? Maybe not. So what is it about dust that blocks visible light? And it has to do with diffraction. So we talked about diffraction earlier, and we said that, for example, if this is a room and then somebody is out here and they're saying something, then those sound waves, when they encounter the door, are going to spread out so that even if you're over here, you would still be able to hear what this person is saying. So that sound waves, when they encounter an opening, like a door, are going to open up. And we say that that was diffraction. And the amount of diffraction depends on the wavelength of the wave. So if this is a wave, then the distance from here to here, that's going to be the wavelength. And so if the wavelength of the wave matches or is larger than the opening that it's trying to go through, then it's going to diffract. So let's take a look over here at what would happen if a radio wave encounters dust. So the black dot is going to be a dust grain. And a radio wave has a large wavelength. So if you remember the electromagnetic spectrum, and you had on one side the very large radio waves, and then on the other side of the spectrum was the very small gamma rays. So the radio waves have very large wavelengths. They don't even notice the dust. So they go right through it. Okay, infrared, notice, has a smaller wavelength than a radio, but it's still large in comparison to the size of a dust grain. So again, infrared can penetrate dust. Now look at visible though. So the wavelength of visible light is approximately the same size as the size of the dust grain. So what will happen is that that light, when it encounters the dust grain, is going to be scattered due to diffraction. And then look at ultraviolet. So ultraviolet has a wavelength that is even smaller than the dust grain. So again, it doesn't really interact with the dust grains. So visible light does, and if you want to cut through dust, the best part of the electromagnetic spectrum to use would be the infrared part. Okay, let's take a break, and when we come back, we're going to talk about 3 different types of nebulas.